All right, we are going to test the latest Llama models, 8 billion, 70 billion, and 405 billion, with five increasingly complex word problems. These problems can be asked in multitudes of ways, meaning each one of the sentence combinations can be shuffled, and LLM performance actually differs depending on which combination of the sentences, the arrangement actually matters. So the first one is a bumper car ring problem. You can read it, but the answer to this problem is 23 yellow cars. Second problem is about a homework in which the correct answer is 24%. The third problem is Alice has M sisters and M brothers. How many sisters does Alice's brother have? Which is M plus one, because Alice is a sister as well. And the fourth problem is the exact same as the third problem, but with some decoy sentences introduced in. It's like her mother is 44 years old and has three sisters. It has nothing to do with it. We also introduced two empty sentences at the end of the problem three to actually make the total combination sentence shuffling combinations to 24. So this first two problems is five sentences and 120 combinations, and the final two is 24. Let's just go ahead and run this. We're gonna first run 8 billion, then 70 billion, and 405 billion. I haven't done this before, but once we run it, we'll get the results, and then we would be able to compare them to the results from the previous models. Sonnet 3.5 did actually the best in almost all problems except GPT-4o did well on the LS plus problem. Well, let's just see how it goes. So we got the first result for the first bumper problem for 8 billion, and it actually got 102 correct, which is pretty impressive. This is the bumper car problem. As you can see, previous Llama 3 actually did 106. So actually, it's right up there with it. I guess it's not exactly an improvement. You can see that the best results for this particular problem came with GPT-4 Turbo, which answered all combinations correctly. Then Sonnet 3.5 with 118, Opus with 117, and GPT-4 Mini at 119, and GPT-4o at 117. So now the Llama 3.1, 8 billion, is working on the second problem, the Marcus homework problem, in all sentence combinations. Here we actually went to the 70 billion, which worked on the bumper car problem, which got 118 correct. So that is very good, 118. Previously, not Llama 3.1, but the Llama 3 had done 117 correct here. So that's pretty good. Let's see what 405 billion does. The code files for this reasoning test is available at my Patreon. Link will be in the description. If you'd like to get a code review of this, you can go to my website and actually search for reasoning tests. And I've performed this many times before. And in the original few two videos, I've actually reviewed the code for it as well, but you can download it from my Patreon. It has three files, one for OpenRouter, one for Anthropic, and one for GPT models from using OpenAI. They're all the same except different providers. I have added the new models here as well, so we can input the results at the end. So here's the 405 billion. You got all of it correctly, the first problem. And the only other model that had done it full correctly was GPT-4 Turbo, and GPT-4 Mini also got pretty close. But this is the easier of the problem. So now we move on to the next problem, Marcus problem, which is more difficult, and 8 billion is working on it, and it's getting quite a lot incorrect. Okay, we got the results for 8 billion on Marcus problem. It only got 7 correct. That's not good. Previously, the 8 billion actually got 10 correct, so it's actually worse than that. Let's see how the 70 billion does. I have added the results to the bumper problem. Yeah, this is not so reflective. As you can see, models usually do pretty good in that. But you can see that in the Marcus problem, 8 billion really didn't do very well at all. Even 3.5 Turbo gets 20 correct. Okay, we got the result for 70 billion for the Marcus problem, and it got 65 correct. As you can see, it's, I suppose, not so bad, but nowhere near how the larger models perform here. GPT-4o Mini, it's right up there with GPT-4o Mini, too. So that's pretty good, I suppose. And Mistral, the 8x22 and Wizard 8x22 didn't do well here as well. Haiku did 66. So now we are getting the answers from 4.405 billion, and it is getting some incorrect, quite a lot maybe. The inference through Open Router seems quite slow. I've used this through Grok and it's very, very fast. You can watch the coding walkthrough of a Llama 3 for 405 billion writing assistant at my YouTube channel at EcoHive. All right, here's the results for the Marcus problem from 405 billion. Got 90 correct. So looking at this, this is not very good. I mean, in comparison to Sonnet 3.5 or GPT-4 Turbo, it's kind of right up there. Opus also did better, but other than that, it beats like Gemini 1.5 Pro, for example, by a little bit. But let's see how it does with the Alice problems. This should go actually quickly. So here, 8 billion, only got 4 correct. So this is the hardest of the problems, but there's only 24 combinations for this. As you can see, Sonnet 3.5 did here 21, and GPT-4 Mini also did 4. Surprisingly, the 70 billion also only got 4 correct on this one out of 24. Let's put it in there. And for 405 billion actually got 15 correct. So that's actually surprising. That's pretty good, but still not as good as Sonnet 3.5. So we are waiting on 8 billion to do the more difficult Alice problem, but we can see it's getting almost all incorrect. By the way, you can introduce your own problems here. The script is designed to actually shuffle sentences in every combination. As long as your problem doesn't change its meaning when the sentences are shuffled, you can insert as many problems here as you'd like, and you pass the list, and you define your model names, whichever ones you want to use. Okay, the 8 billion on the more difficult Alice problem got 0 correct out of 24. Let's put it here. But so was the case with GPT-4 Mini and Gemini 1.5 Flash and Pro. Even Sonnet here did only 2 correct. By the way, you can modify the system message. As you can see, the system message that we're passing is just that you're a perfect logician. You can actually test out different system messages here as well. So we're waiting on 70 billion, but it looks like it is getting all of them incorrect as well, and it got 0 correct, unfortunately. Let's move it here. Now, let's hope 405 billion does better. Like I said, the code files for this will be available at my Patreon. Link will be in the description if you're watching this at YouTube, and in the comments if you're seeing this from X. Okay, so we got results for 405 billion. For the more difficult Alice problem, it only got 2 correct. So this is what it is. This make of it what you will, but I'll post a snapshot of this at my Twitter account as well. So all in all, I guess they're good, but they're not the best. They're, I guess, one would say average, perhaps, but they are pretty close to the larger models, I suppose, and they are open source, so that's a great feature value, I suppose. So thank you for watching, and see you in the next one. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.